Keep it. It's coming. That's what we do. We work mainly on computer vision. So first of all, let me introduce again myself. I'm David Lopez. I work as project manager in artificial vision department. We work mostly with our workmates in data science and artificial intelligence. And today, I'm back to tell you some of the things I couldn't tell you last year. That's the reason because we call this chat uh, volume 2. So an image is worth a thousand words, volume 2. But today I'd like to introduce you in the first place the way that we follow to reach the point where we can apply these artificial vision techniques. So how we apply the machine learning and when can we do that? When we have a process that is capable to receive this kind of technology. So that's the reason because we call this the path to artificial intelligence. Before going into the path of the artificial intelligence, I also like to just remind you the way we used to work with image. Here you can see like a classic schema of supervised learning while we are using a convolutional network. You know that a convolutional network applying for images, what it tries to do, it tries to get relevant information of an image. It's not about to get the pixels or the image itself, but to take the key points, to take the color, to take the edges, whatever that might be relevant to your process. As I mentioned, this is the classic schema, but nowadays the state of the art is kind of revolutioning this schema. That's true that it's supervised learning, but if we move the other way back, the schema, if we consider that we got that key points of an image, the key point that will let you recognize the raccoon that was from previous year, we are capable to create new images that is called Big Gun. So imagine that you got the key image, the key points of the image, and you go back, and with the key points, you create a new image. So it's kind of removing or reinventing the state of the art. Also, if we remove all the input labels, we are capable to create unsupervised learning. That's just the introduction. But when do we use machine learning or artificial vision? Why do we do that? We usually define a process the way that is just a bunch of action that when they receive a stimulus, when they receive an input, it creates an output. That will be the definition of a process. So the key here is when we apply machine learning, when we apply actually big data, we do that because we are looking for more insights of our process. So we want to automate and tuning the process the way that we are capable to learn about the process, to make it better, to improve it. That's the main reason, and we have to keep it in mind when we talk about automating anything with machine learning. We do that because we want to improve our process. So we need insights. Once we get the insights, we can apply machine learning in order to tune the process and to keep tuning it by learning any modification. So step one, I'm just creating the process. I have no information. It's me alone in the mountain, and we call this phase individual contributor. And I like to just let you imagine that the data is represented in the image with the path. It's only me who is walking through the process. It's only me who is creating the data. And that's true that the data is quite narrow. So in this phase, when we talk about individual contributor, it's the phase where the process is born and only one person is managing everything. To give you an example, if you think about a production line and you have a quality control, the person that is checking that the piece or a motor engine it's correct, he does because he knows how to do it. There is no standard, there is nothing written down. So it's only because the way the engine sounds, the way he used to just watch the piece, like say, okay, this seems to be all right. I need to discard this one. But we can think also in a hotel, right? Uh, when you just open your hotel and you only have one person to manage the hotel, the same person will be the one that will just make the bed, take the phone, make all the bookings. So that's the phase where we call individual contributor. I'm not saying that if you stay along the path, it's path, or you need to go directly to the end. Actually, the nice thing about machine learning is while you try to apply machine learning, you will follow, or I strongly recommend you to follow this path. So here, it is cheap. You only have to pay one person. Anyway, the data you are generating is limited, so you cannot grow up. So next step, what you are gonna do is step 2, we call delegation. So we create we hire new employees, we split the tasks, and it's really important this phase, not because we are gonna generate a lot of data, it's only because we are gonna to define the standard. And it's really important to define the standard. In the previous one, you don't have any standard, so you cannot compare. You don't have the definition of error. An error means that it's out of your standard. And when you try to explain a new person how to perform a task, you have to have that standard defined. So that stage, that's the point where you will have that definition. And it will let you define later on your KPIs that I will chat about it later on in this presentation. So okay, I have more than one people just working on my company. In the previous, if I stay in the step 2, my cost, it will raise, it will increase. So I need to quickly move to the next step. That will be digitalization. As you see now that we have moved and we have introduced new machines in the process or new digital transformation in the process, we are generating more data. That's because we have the road. So here is the first point, well, I'm generating that data that I will exploit later on. So in this phase, well, how do we reach digitalization? Why we call digitalization to this phase? So those processes that you have at least a part of the process that can be automated without losing any user experience. And a clear example of this one could be, well, you are booking the room in the hotel, everyone does via the website. So you have a digitalized process that is booking your room in the hotel, and you are not losing any user experience. Actually, you are getting the user involved because you will no more call the hotel to take a book in here. So you create more impact. You don't have to confuse digitalization with reduce the amount of employees that you have in your company. I'll talk later that every process needs to keep the humans in the loop. So it's not about losing people, it's about to increase their impact. So once we got the data and we got all the digitalized process, what are we gonna do? We are gonna create the insights. Until that part, until the step 3, every decision we took we took based on market shares, I would say, market information. It's not customized to your process. So you are, and you know that not at everywhere it's the same thing. So if you are in Sweden, probably you will not rent, you will not practice surf. So you don't have to sell this kind of bath clothes. So whereas you are in Malaga, probably you will require that things. So you need to customize your process based on the data you generated in the step 3. As you see, like all the steps have a sense. You cannot skip one step. You can do, but you will miss something in the next step. So once you reach the big data and analytics step, you will be capable to decide by your own, based on your data, what might be better for your process, better for your business. And the thing is, at the end of the road, it's machine learning what is waiting for you. Instead of selecting the data manually, that you have a human limitation. That's the only thing you face in step 4. Step 4, actually, you can stay in step 4 like for years. It's nothing else than you will take your decision based on your perception of the world. With machine learning, what you will get is one brain looking for thousands of thousands of thousands of insights and data. So you will keep all the knowledge centrally and automated. So it will let you automate and learn automatically in your process. If you have any change, if I come back to the hotel example, I'll say, okay, we define step 1. Step 2 might be, okay, we have 2 people. One will take the beds, will make the beds, another one that will pick the phones. But for that, you will have to, as I said, define the standard. So the bed to make the bed, you have to do this way, and this way. And when you take the phone, you have to say, hello, this is López Hotel. How can I help you? So you have to define the standard. In step 3, you will automate all the digitalized process, everything that can be automated without losing user experience. If you stay too long in the step 3, the bad point is that all your competitors can go in front of you. So you will stay behind because you cannot customize and tune the process how much the way their competitors are doing. But the step 4 will just take the insights and exploit them, and the step 5 will automatically do the same that you did in step 4. So, all right, we have defined the path of the artificial intelligence, how the process is evolved, all the steps, and so on. But where do we start with the project of machine learning? We think that we are in step 4, and we really want to start doing these machine learning things. Words. This might be considered easy to define the KPIs, but that's true, and that's the reason because I strongly recommend you to follow the path to the artificial intelligence, that if you skip any of the step, it's going to be difficult for you to define that KPI. If you don't define correctly the KPIs, you will do something that will not improve anything in the real world. And for computer vision, that KPIs usually refers to true positive, false positive, true negative, and false negative. If you work with images, true positive is when you say that there is something and indeed it is. True negative, you say there is nothing and indeed it doesn't exist. False positive is when you say there is something but indeed it doesn't exist. And when you say false negative means that you say there is nothing but it exists. Okay? So keeping in mind and depending on the process is really important when you talk about classification or identification of objects to define correctly the KPIs. It happened to us in some project that we define, and we'll see later on. Okay, we have to get a precision, or we have to be really good keeping the false positive in a low rate, or we have to keep false negative in a low rate. That depends of your KPIs. If you are not capable to define those KPIs, that probably means that you don't understand the use case, or you don't understand the technology you are applying. And I'll give you the example. If we work in elections, in public elections, it's impossible to say that something exists while it doesn't exist. That means false positive. So we cannot say a person is voting something that it is not. You can say there is no vote in the ballot paper because you can review later on. So you keep that kind of circumstances under control. But we'll talk about later on the spills, the petrol spills. So if you are considered that the petrol spills can affect the environment, it's better to you to say that there is something, it doesn't exist. That means that might be a petrol spill on the sea, rather to say that there is nothing and it exists. So depending on your business case, I know it's a bit tricky, but depending on your business case, you have to keep it in mind. Depending on if you are talking about segmentation in computer science, computer vision, you will probably use EOU. That means intersection over union, that you can compare what the user is telling you, where the user is telling you that there is anything in the image, whereas you can compare, okay, in the image I said, like the prediction is this way, so you can compare both metrics. But keep it in mind, defining KPIs might be easy if you go through the path to artificial intelligence, whereas you start from zero, probably you will make a mistake, so the basis of your project might not be the correct ones. But when we have defined the KPI, we have the definition of success and the failure. Next step, everything, every time, in every single project, when you talk about machine learning, we'll be collecting data. There is also a pitfall related to this step, but you can do nothing if you collect data. And you have to keep in mind the project you are attacking here. If you are tackling a project that you will take the image later on during the night, your dataset must include image taken during the night. If you will take a project that it's involved in the cinema, for example, you have to take relevant information. If you're gonna, it's no sense if you're gonna take satellite images and you take images from the helicopter just to train your models, because it will not work. So it's not only about collecting data, but also take relevant data. So now that we have the definition of success and we have the data to start with, we'll build the infrastructure. Build infrastructure means, and I love the talk that our mates from CEPSA, they spoke before. It's important to know where you're gonna exploit your data and where you're gonna do the inference. So define correctly the architecture and define correctly the neural network or whatever computer vision technique that you're gonna apply. That's something you will do here. So it will not be the same if you're thinking to work on the edge rather than to work on the cloud, rather to work on a physical infrastructure. That's something you have to keep in mind, because as I mentioned, the people from TEPSA, you cannot use a really complex neural network or really complex algorithms if your computational engine is narrowed. So keep it in mind before doing anything, because you will define later, based on that requirement, you will define correctly the architecture on the client side. Definition of success, collecting the data. I got my infrastructure, and what we have to do here is optimizing the ML algorithm. And I say ML, but it could be any artificial vision technique, whatever. It's not really about, when we talk about optimizing the ML algorithms, I'm used to refer to select correctly the hyperparameters, to select correctly the package on the buckets, okay? And finally, as we do not live alone, we have to integrate our solution within our client systems. So how people see our effort from outside, and that's a surprise. And I recognize it happened to me at the beginning. So it's like 15% KPIs, 10% of recollecting the data, 10% of building infrastructure. You will spend a lot of time just optimizing your machine learning algorithms, and probably you just will create a TXT file or whatever, and we will integrate later on. And that's a mistake. That's completely a mistake. Every people, they work with images and they work with machine learning, they will realize and they will confirm you that collecting the data and to clean them will take a lot of your time. Even if you have your data beforehand prepared, it will take a lot of time for you. And you will not spend that amount of time just optimizing your machine learning algorithm, because you will spend most of the time building your infrastructure. And there is small difference there, because optimizing your machine learning algorithm means that you have select in a quick time your machine learning algorithm, but it's not true. When you talk about building infrastructure, I refer that you have to keep training with more and more data your machine learning algorithms. That's something that if you don't do, you will not be universal, and you will not consider some of the scenarios that you will face later on. So you will make a mistake. So keep it in mind, like collecting data and building infrastructure. Really, I don't know anyone that works with images that can say that collecting data is just a small amount of effort. Probably you will underestimate that phase. So people used to say you will learn more of your mistakes. I used to say that you will learn more about your success. That's true. Every time you success, you only have to repeat that formula. But if you fail, you shouldn't consider a complete failure here. But that's 9 usual pitfalls that the people used to do while applying these machine learning techniques, while they are facing these machine learning projects. The first of all is to think that artificial intelligence will require a small amount of time or a small amount of infrastructure if you compare with your classic development, computer science development. And it's not true. That's the people, they jump directly from step 2 to step 4 or step 5, that they will tell you this thing. Once you are working with artificial intelligence, that's true that your effort while developing will be less. But you will have a lot of action you have to take in order to make this work. And this is classic. I think every single chat, every single talk that you see here, they will tell you, if you have no data, you have to stop. It's no sense to try to do something if you don't get the data before. So stop at that point, collect the data, ask for advice, but do not start directly with your projects. And if you get the data, do not assume that the data will be ready to use. So probably you will have to clean a lot of data that you get. Probably because you have some dirty on the image, probably because the perspective is not right, probably because you are a lot of sun in the image. I mean, thousands of possibilities here. And I said before, like, you have to keep humans in the loop. I will speed up because I'm running out of time. You have to keep humans in the loop. I said before, machine learning is not about to remove people of your company, and it's to increase their impact. While you are creating a new project related to machine learning, you have to keep those people growing up with your project, with your process. So it's a mistake to think that your automated machine learning process will solve everything in the world. that's not true. There will be something that you will not be capable because you have not you require more images, or you don't have the computation process engine ready to use, because they say that the state of the art is just changing all the time. But for those cases where you cannot reach the very end of the process, you have to keep human learning with you. So that's important. And that's this one is pretty common, even it's not that important, but when you launch a process, when you launch a project, and your future is that you use machine learning, the user will not understand that. The users, they will not want a project, they don't want a product because they use machine learning. It's because you actually are improving things in real world. This also a mistake, like you try to improve or to optimize something that doesn't need to be optimized. When I'm talking about making the bed, no one thinks that I need to create a robot so the bed is performed even better. That process is so far so good. But just put your effort in things that will really improve the user experience, and it will actually be improving in real world. That's true, and there is only two more, and then I will start with the project. But you shouldn't think about create your customized, super nice, cool-looking machine learning algorithms. I strongly recommend you to start with a pre-trained machine learning algorithm, so you will save a lot of time. So don't do that. Actually, it's a waste of time. And when you think about machine learning, and I really like this picture, why this child is winning all the rest of the people. It's only because it's considering the rest of the plays that he is facing. So if you play chess the first time, you will not be the master of the chess. Once you have played sometimes, you will get some experience, so you can expand your knowledge about chess. But once you are facing different people, you will incorporate all the information of those situations. So we can think about the same situation, same scenarios, while we are deploying our machine learning. So we have to, the first time that something weird occurs, you will not be capable to perfectly react. You will react. You have the confidence to do that. But every time you retrain and incorporate new images, you will improve your machine learning algorithms, for sure. So don't think to just train once. A lot of things, right? That was pretty theoretical. But let's go with the practice. How we do that? Where we do that? So I select this retail thing. We talk about image recognition and product recognition. So this project, what we were doing is we have people just going through the supermarket and just take a picture of the shelf. What they were asking us is to recognize every product that it belongs to Pascual Discans. So first of all, we define the KPIs. At this point, the KPIs is to get every single product recognized in the image. It's not about to get a 99% of your product recognized in the image, but to get the 100%. And you have to take that into consideration. And here's that important to recognize the product that you are looking for than to recognize the other product that you are not looking for. So you first of all need to segmentate all the images to take all the important information. You have to remove the self so you can calculate the height. And also it's important to realize that there are some products that will change along the path, but I'll let you see later on. So once you get the product, you will extract the key points or the key features of the product. That's something I start the talk with. So in this case, what we are gonna get is the key point instructions, okay? I'll just take some image considerations. I'll take the color into consideration, and also I'll just check the size, because this problem is possible to get kind of the same product, but with a different scale. But you know that every image you take is different, and we can see that. Like all the pink products, once you, depending on your environment, it will be darker or a bit lighter. And it happens all the time. That's the reason, because I told you, like, you have to consider all possible situation here, because you need to recognize that product in every single scenario. So what we did is just take under consideration that key features, and we just draw a diagram and put a weight. So we can just stay together, like, there are some products that could be grouped. They will clusterize here. This another one. It depends also. We recognize single products, the pack, and also when you have two on the products. So once we get a new image here, we'll try to just assign to the closer group. It was easy to think about milks that I showed you before, but when we talk about water, there is no really color information on there, that the part that you're looking for is quite anything. Like there is nothing to check. That's a real image that we get. And that's the real scenario we're moving on. So we are capable to recognize not only Bezoya, that is the case, but to know that those other products that they seem quite similar, they are not the ones, or maybe the Fondela. But it happened with everything. Like you can have, as I said, it's important to know your true positive, but it's also important to know your true negative here. I talked before about Petrol Spills controls. What we get here is a combination of different inputs to generate a correct image. So if you think about a Petrol spill, what you will realize that probably it will not have the same temperature rather to the sea. But that's true that at some points in the sea you have also different temperatures, so you need to incorporate rather than one input. So it's not only about thermal analysis, but you have to get like common vision analysis or even radar. That project we made with commercial sensors. We do not create anything rather than just take the cameras and put just looking for the sea. And this is the kind of things you will see. This is a petrol spill. So it's important to recognize, and I go back, that part is the petrol spill. That can be like a piece of cake, right? Like, don't make fun of me. That could have to be easy to recognize. But when I move, and I ask you, like, this is a petrol spill, and I have to tell you, like, it is not a petrol spill. This is just the sea changing their temperature. So you have some flows under the sea that will change your temperature. And to be capable to distinguish of these things, you have to take under consideration things like the movements that the petrol will have, so the way they move, compared with the flows. You have to take under consideration the way they are grouped, like the petrol spill will just flow together, whereas the flows can be just creating some branches. So the point is, you have to take under consideration more than only one input. That's the thing where machine learning and artificial vision will increase and improve your process, because it takes under consideration different sources of inputs here. By the way, that is quite similar to this one. I have to say that's a petrol spill. So we have true positive here. That's some preferences that we have in Spain and also Latam. And I really like this one because it's also quite impressive. So how you detect the defects where you are just looking for car insurance. Well, first of all, we have to consider the way that we take the information of the environment. So in this case, we define, okay, we have to take 8 different angles. So we capture an image from all the sides of the car. And it's important to keep it under control, because machine learning, it will only replicate or it can infer something that they have seen before. You can infer something you didn't see before, but you will not have the same confidence. So as much as you narrow your scenario, the better improvement or the better measures or KPIs you can get. So we define it, the way to capture. And once we got an image, we define the process to follow. As I said, you have to keep humans in the loop, because what happens if you see a car with structural damage? So structural damage, you cannot, at this point at least, we cannot say this means 300 euros, because we don't have the knowledge to do that. However, we have the knowledge to detect that damage and to just ask the user to do by their own. So first of all, we will just remove all the background that we are not interested in. We keep the vehicle. Once we keep the vehicle, in this case that I'm showing to you, we'll keep the front. So first thing we have to do is just segment the image. And when we have segmented the image, we have to segment the subcomponents of the component that we are analyzing. So next step is to define what a defect is. And here you can see how we are working. Like we have the ground truth. That means a user just saying that that's the front bumper, and we have the prediction. So we are over 92% of the EOU. I mean EOU, like if you join the ground truth and the prediction, it matches up to 92%. So really nice metric. So first step, I said, just keep the front bumper. Once we got the front bumper, we look for the structural damage. And when we got the car and we know that it's only normal damage, I will say, we have to predict it. And there, what you're seeing is blue, green, and red. Blue means that the user is saying that on that side there is a defect. Green means that in the part that the user is saying there is a defect, our prediction matches with the user. And in red is the prediction that they are saying, the prediction is saying that there is a defect, whereas the user didn't detect it. You will consider red like false positive. But to be fair, it is not. Because what we have seen is that computer vision used to work even better than the user just looking for damages. So here is kind of difficult to define the KPIs, because you cannot be sure that the user is telling you the truth. I mean, they are telling their truth, but you have to keep analyzing by your own. I really like this one. It's really impressive to detect this kind of defects. Where else? So thank you. I'm sorry because we have a lot of projects like in the energy side, like we are just looking for high power, medium power, like grids. You are following all the cables and so on. But I have no more time to bring them here. Anyway, I strongly recommend you just with some more extra time. I will be just next to the stand, this Minsait stand, so you can just come closer and we can talk later on. But if you have any question here, just be free to ask anything. Everything clear, so. Okay, thank you for the time, and I hope you enjoy it.